basically going to be a multiple of an empirical formula. So for number 1, it says vinegar is a dilute solution of acetic acid, and the molar mass of acetic acid is 60 grams per mole. The empirical formula for acetic acid is CH2O. They want us to calculate the molecular formula of acetic acid. I'm going to write a few of these things down. Empirical formula, I abbreviate as EF. Molecular formula, I'm going to abbreviate as MF. They gave us an empirical formula. They said it is CH2O. So that's the empirical formula of acetic acid. The molecular formula that I need to figure out has a molar mass of 60 grams per mole. Since the molecular formula is a multiple of the empirical formula, what you want to do is calculate the molar mass of CH2O. We're going to do that by looking at the periodic table. So when you look at your atomic mass periodic table, what is the molar mass for carbon? 12.01. So I have 1 carbon in the empirical formula. How many hydrogens are present? 2. So 2 times 1.01 for hydrogen, and then oxygen's molar mass is 16, and I only have 1 of them. When you add all of these together, you're going to get 30.03. So 30.03 is the molar mass for the empirical formula CH2O, okay? Since the molecular formula is a multiple of that, what would I be multiplying 30 by to get it to 60? 2. Yeah, so 30 times 2 equals 60. So that means you multiply this empirical formula by 2 to get to the molecular formula. So when you multiply this by 2, how many carbons will I have now? 2. How many hydrogens? 4. How many oxygen? 2. This is your molecular formula. Okay? I want you to look at the worksheet that I gave you, and I want you to do number 1. It's just like this. The molar mass of the empirical formula part right here? Yeah? Okay, so since they gave us 60 for the molecular formula, I need to calculate the molar mass of the empirical formula because this 60 is a multiple of the molar mass of the empirical formula. So I had to calculate that first and then figure out what do I multiply that by to get to 60. And that's how I figured out, yeah. Okay, how many of you have got an answer for number 1? Okay. Okay, can I go on to number 2? All right, in number 2, they tell you that a compound has an empirical formula of C3H4. Which of the following are possible molar masses of the compound? So what that means is they're looking for possible molar masses of the molecular formula that would go with that empirical formula. So what I'm going to do is I'm going to calculate the molar mass of C3H4. What is the molar mass of carbon?
12.01.
12.01, and I have 3 of them. So 3 times 12.01 for carbon. And then how many hydrogens do I have? 4. 4 times 1.01 for hydrogen. We're going to add all that together. You'll get 40.07 grams per mole for the molar mass of the empirical formula. That means out of these possible molar masses, you want to look for multiples of 40.07. That means higher than, either equal to or higher than. Would 20 be a possible molar mass of the molecular formula?
No.
No. How about 55? No. How about 80?
Yes.
How about 120?
Yes.
Okay. Let's take a look at number 3. So number 1 asked you to do, this was a small, molecular formula problem, okay? That's the basic, okay? Number 3 is the long version of calculating the molecular formula. So number 1, they gave you the empirical formula. Number 3 wants you to calculate it before you do all of this, okay? So let's take a look at number 3, and I'll walk you through it. It says a sample of antifreeze was analyzed. It has 4.51 grams of carbon, 1.13 grams of hydrogen, and 6.01 grams of oxygen. From the elevation of water's boiling point, it was determined that the antifreeze's molar mass was 62 grams per mole. They want the molecular formula of antifreeze. So since they did not give us the empirical formula, you have to calculate the empirical formula. Okay, so they gave me grams. So what do I do with that first? What do I convert grams to? Moles. Okay, so what is the molar mass of carbon? 12.01. What's the molar mass of hydrogen? 1.01. And then what's the molar mass of oxygen? 16. Okay. Do I round off to the proper number of sig figs here? No. I take my moles like 4 or 5 places beyond the decimal, and I don't round. So There's my moles. What do I do now?
Divide by the smallest.
Divide by the smallest mole. So my smallest mole is probably this one right here. Okay, so when I divide each mole by the smallest mole, I'm hopefully within 0.1 of a whole number. So this is 1, this is 2.9, and this is 1.0, which is just 1. What will I do with the 2.9?
Round it to 3.
Round it to 3. So these are the subscripts in the empirical formula. So my empirical formula is CH3O. Now you add on what we did in problem number 1, where if I'm calculating the molecular formula and they gave me the molar mass of the molecular formula in the problem, I have to calculate the empirical formula molar mass. So I've got a carbon, 3 hydrogens, and 1 oxygen. So if I add all those things together, you're going to get 31.04 grams per mole. This is the molar mass for the empirical formula. Okay? 31 times what is 62?
2.
Yep. So if 31 times 2 is 62, you would multiply the empirical formula by 2. And what would that give me for the molecular formula?
C2H6O2.
Exactly. There's my molecular formula, C2H6O2. Okay? That's enough for you to do the worksheet.